Alright, you guys, we want to do the second section of 3.1, properties of parallel lines. We're going to focus on the two proofs you're going to have for homework today. And we're going to do a proof, and the difference between this proof that you're going to do is now you have to come up with your own statements. So we're going to develop proofs today using the theorems that we have about angles and parallel lines. Alright, so I'm going to use this as an example to do these proofs, and I just want you to watch how I'm going to do this, and I want you to know there's a lot of ways. The way I'm going to direct you on this proof is only one way. There's many different ways you could do the same proof. Okay, very first thing is notice we have no statements and no reasons, and so when you're doing proof, the proof setup say draw the picture. In this case, your picture is provided, and write down what you're going to prove. So here's what you're going to prove. So we're going to prove that angle 1 and angle 4 are supplementary. This is what we're going to prove. Prove angle 1 and angle 4 are supplementary. So the very first step is to write down what you're given, if you have given information. And I do have given information. I'm given that A is parallel to B. So I'm going to write A is parallel to B, and the reason I can write that is it's given to me. Alright, now that we have parallel lines, that's clearly cut by a transversal. Don't forget we have all kinds of angles here. We only have two interior angles and two exterior angles, and there has to be relationships. I'm looking for either the letter F, the letter Z, or the letter C, and I don't see anything right now except for the letter F. Now I could use either angles 1 and 3 as being corresponding, or angles 2 and 4 as being corresponding. So I'm going to introduce angles 1 and 3. I'm going to use these angles right here. Here's my letter F. I know that these angles right here have to be congruent angles. So I'm going to say for my second step that angle 1 is congruent to angle 3, and I know that for a fact because the corresponding angle postulate tells me that. Corresponding angles. If we have parallel lines, and we do, then corresponding angles are congruent. Alright, I have 1 in there. Now, the other thing is, I've got my angle 1 in there. Somehow I have to introduce angle 4. And I have to introduce angle 4 in the way that means this word supplementary. I need a supplementary. So now what I'm going to focus on is this. This is my protractor. Don't forget with a protractor, I know these angles add up to equal 180. So I'm going to say that. I'm going to say angle 3 plus angle 4 equals 180 degrees. And I can say that because of the angle addition postulate. Now this is really a very important step because now I can introduce the word supplementary. You guys know by definition that if two angles add up to equal 180 degrees, those two angles are called supplementary angles. So I can introduce my fourth step. I can say angle 3 and angle 4 are supplementary. And the reason why I can say this is by definition of supplementary angles. By definition, supplementary angles are two angles that add to equal 180 degrees. I'm almost done. I'm trying to show angle 1 and angle 4 are supplementary. I have the angle 4. Somehow I just need to get rid of this angle 3 and replace it with angle 1. But I can, because of this statement right here. I can put this into 3. I can replace 1 with 3 because they're equal. So I'm ready to make my final statement of my proof. My final statement of my proof, step 5, is that angle 1 and angle 4 are supplementary. And the reason is simply substitution. What am I substituting? The information from step 2 into 4. Step 2 goes into step 4. That's where my substitution occurred. I'm done with my proof because my very last sentence, take a look at this last sentence, the very last sentence, the very last statement of your proof will always match what you're trying to prove. And I'm done with this proof. Okay, that was just one example of a proof. I do want to show you, kind of review with you a little bit of what we did before. So let me clear this ink and go over a couple more problems on the bottom of your notes. It says in the diagram below, M is parallel to N, which is why you see these arrows right here. And you can clearly see it's being cut by a transversal. I definitely have some interior angles right here. Those are my interior angles, 3, 4, 5, and 6. And now I can answer these questions, or I hope you can. So complete this sentence. What angle and angle 4 are alternate interior angles? So I find angle 4, and I need to make the letter Z shape. So I'm going to continue this along my transversal. This is angle 4, so angle 6. So angle 6 and angle 4 are alternate interior angles. Alright, let me complete the next one, number 2. It says, complete. What angle and angle 8 are corresponding angles? Alright, corresponding angles look like the letter F. So I'm going to find angle 8, mark it. I'm going to follow my transversal up until I hit my next line, and I've created my angle, my letter F. Here's angle 8. It's matched up with angle 4, so it has to be angle 4. Okay, let's erase my ink colors. It says, suppose angle 3 equals 37 degrees. Let me mark angle 3. They're giving me angle 3. They want to know what's the measure of angle 6. Let me mark angle 6. Oh, I got a letter U. What kind of angles are those angles? These are called same side interior angles. Same side interior angles are supplementary. They have to add up to equal 180. So angle 3 plus angle 6 together equal 180 degrees, of which angle 3 is 37. So I'm going to subtract 37 from both sides. Angle 6 is 180 minus 37. Let's see, 180 minus 37. Borrow. 10 take away 7 is 3. 7 take away 3 is 4. 143 degrees. The measure of angle 6 is 143 degrees. So let me write this down. The measure of angle 6 equals 143 degrees. Alright, last one. Suppose that angle 1, let me erase my colors. Suppose that angle 1, let me find angle 1. Here's angle 1, is x plus 12, and measure of angle 5, let me find angle 5. Here's angle 5, is 3x minus 36. First, what's the relationship? This looks like the letter F. These are corresponding angles. Corresponding angles are congruent. I know angle 1 is equal to angle 5. So substituting in, x plus 12 has to equal 3x minus 36. I'm going to simplify this, subtracting x from both sides. 12 equals 3x minus 36. Add 36. I get 48 equals 3x divided by 3. x equals, well, 3 goes in there one time, 6, x is equal to 16. I found x, I'm done with the problem. So this is how you do these types of problems. And this was just a review of what we did in the first part, but more importantly are the proofs. Number 9 and number 28 are both proofs.